Hello and welcome back for another VMK in the C++ series. In this VMK I'm going to describe how looping structures work in C++. So we'll cover the while loop and the for loop. There are a couple other looping structures in C++, but I'm just going to describe these two because those are the ones that I most commonly use. And as a matter of fact, you can pretty much do anything you require with these two looping structures. You don't really need the other ones. Alright, so let's get started. We'll go into Visual Studio here and create a new project. And again, it's going to be a simple Windows 32 console project. And let's call it Loops. Under Application Setting, make sure you have Console Application selected. And when you click Finish, you'll have the general main structure already constructed for you. Now what we're going to do is we're first going to create a variable. And this variable is going to keep track of how many times we're going to display something to the screen. We'll use a looping structure to loop multiple times so we can display different numbers to the screen. Let's take a look at how this works. I'm going to create an integer. I'm going to call it iValue. And initially I'm going to set this value equal to 0. Now the first looping structure which I'm going to describe is the while loop. And this is how it works. You type in the keyword while, and then in brackets, you want to put in a condition in here. And while this condition is true, you will continue looping through the loop. If this condition goes false, then you will stop looping. So my condition is going to be iValue less than or equal to 10. So in other words, while we're going into this structure here, I'm going to be updating the value of iValue. And the way I'm going to be updating it is I'm just going to be adding 1 to the value every time. So this notation here, iValue plus plus, this is actually the same thing as writing this out. iValue equals iValue plus 1. It's just a short form notation in C++ to do the same thing. So as I do this, what's going to happen is I'm going to initialize my iValue to 0. It's going to go in here and check to see if iValue is less than or equal to 10. If it's true, it's going to go inside of this while loop, increment iValue, and then come back out and check again, and so on. Now, I actually want some work to be done inside of this while loop while we're in here, so let's just print f, and we're going to display the current number to the screen. You've already seen the printf's notation before, so I'm not going to go into any detail about it. And after the while loop is done, we're just going to go and return from our program. So holding Control and pressing F5 on the keyboard, we'll build our program and run it. And as you can see here, we go from 0 all the way to 10. So we have 11 instances inside of the while loop. We go 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. And then we basically quit. So this is one way to use the while loop. If I only wanted to have 10 instances rather than 11, then we could start our loop at 1 rather than 0, and you'll see now that our counter starts from the number 1. We can achieve the same sort of while loop using the following notation. Instead of moving our condition in here where it's right beside of the while keyword, what we can do is make an infinite loop by doing the following. Because our condition is always true now, we'll always be going inside of this while loop. But we don't want our program to continue running indefinitely. We want to have a escape condition. And the way we can do that is with an if statement. So now we can put our condition to stop our program inside of our while loop. And to cause our execution to actually exit out of the while loop, we need to use another keyword, and that's called break. So now, what we've done is we've set up our condition inside of the while loop, and it's going to do exactly the same thing we did before. Let's go run our program, and oh, we made a mistake here. We actually don't display anything to the screen because if we take a look at our logic here, we need to reverse some things. We go inside of the while loop always, but in the first instance of this if statement, iValue is 0, so 0 is less than or equal to 10, so we do break out, which is not what we intended to do. What we want to do here is check to see if iValue is greater than 10. If it's greater than 10, then we want to break out. Otherwise, we want to continue looping. So let's try this. All right, there we go. So now we again display the numbers from 1 to 10. Now, note one other thing here. It's very important to note where you place your break statement. If you place it before you do your work, then you get the behavior I just showed. If you place your break statement after you do your work, then you're going to get the following. Now with this execution here, you notice we have the same output that we had before, but it's working a little bit differently this time because it's printing before it's doing the check. So if we go back to our previous case here where we have I value less than or equal to 10, you'll remember before we had nothing being displayed onto the screen. But this time when we run it, you notice that the number 1 is displayed and then we break out. So you have to be careful where you place your break condition with respect to the work that you're doing inside of the while loop. If you place it at the end, you're going to execute this stuff before you break out. If you place your break at the top, then you'll break out before you do your work. So it's important to understand what it is you're trying to achieve with your while loop so that you can construct it appropriately. The other kind of loop structure that is heavily used in C++ is the for loop. And the for loop looks like this. You type in for, and then you have 3 arguments. You have the first argument, then you have a semicolon, you have a second argument, another semicolon, and then your third argument, and then your closing bracket. Then you have your opening brace and your closing brace for the actual work that you want to do inside of your loop. Now these 3 arguments do different things. The first one is executed only once, the first time through. The second one is your check to see how many times you want to be executing. And your third one is your incremental value, so what you want to do after you've finished your execution. So this is the way that I would rewrite your while loop here as a for loop. You would type in your I value is equal to whatever you want, let's say 1 initially. So that's going to take care of this initialization at the top. Then we're going to have our check in here, so we're going to check to see if I value is less than or equal to 10. If this guy is true, then we're going to go and loop inside. If this one's false, then we're going to break out of our for loop. So it works the same way as the condition in here for the while loop. And then lastly, you have your incremental value here, so what you want to change each time you go through your for loop. And what we've decided to do is increment I value by 1. So we would write the following. And again, we're going to take our print statement and stick it inside here so we can display our I value every time through. And we'll take this guy out this time. When we run this, we can see we get the same behavior we've seen before, where we get the numbers displayed from 1 to 10. So a for loop is very handy when you know exactly how many times you want to loop through a certain structure. So for instance, if you have variables that are arrays, you use for loops quite a bit. Because arrays, you usually know you have a grouping of 3 variables for a certain array, or you have maybe 10 variables that hold, I don't know, certain kind of element. So you create a for loop and fill in all 10 items all at once. You could use a while loop, but it's not nearly as nice for that. What you want to do with a while loop is use that if you're not sure how many times you're going to be looping. For loop, you should know how many times you're looping. While loop, you may not necessarily know. Now what do I mean by not necessarily know how many times you're looping? Well, your loop may be dependent on a variable that's changing as your program is executing. And once a certain condition is met, then you'll want to exit out of your for loop. Let me demonstrate how that can work. Let's say that we want to create a C++ program that generates a random number between, I don't know, 1 and 10. And every time we generate this number, we want to add it to a sum value, which will just collect the total number that we've added together. Once the total number reaches greater than 100, we want to exit out of our program. But because it's a random number generation, we don't actually know how many numbers it will take before our total is greater than 100. So in this case, you'd want to use a while loop. Let me demonstrate how we could program something like this. We'll use a floating point number this time, so I'll use fValue as our variable name. And initially, we're going to set this guy up to 0. So we don't have a total. Now we're going to create an infinite while loop, so we'll set this guy up to true. And our breakout condition from our while loop is going to be if f value is greater than 100. If that's the case, so I should make this a floating point number. If that's the case, then we want to break out. And we also want to display the value of fval, so printf it to the screen here. And I'll round off some decimals so it's a little easier to read. Fval, like so. And the only thing that's missing now is our random number generator. Inside C++, there's a function called rand, and what that does is it returns a number between 0 and a large number. And the maximum large number that it can return is defined by a macro. If you go into MSDN and take a look at the rand function call, you can take a look to see the details of it. And you can see here it says it's a pseudo-random integer that gets generated between 0 and rand max. So if I want to generate a number between, I don't know, 1 and 10, then what we can do is take that number, divide it by the maximum value that it can output, and then multiply that total by whatever number we want to range to. So if we want a number between 0 and 10, we'll do the following. Random divided by random max, this will give us a number between 0 and 1, and then we multiply that by 10 to give us a number between 0 and 10. So what we want to do is take that number and add it to our total. Plus equals is a shorthand notation for the following. Fval is equal to fval plus whatever we have after the equal sign, which is all of this. Okay, so let's go and compile this and give it a run. Alright, so we can see here now our total is displaying on the screen, and then it's once it's greater than 100, our program quits. The strange numbering that we're getting on the screen is because our random number generator is actually outputting an integer, but we're dividing it by another number here, which we want to have as a floating point number. So instead of writing our equation here in brackets the way I've done, what we need to do is rewrite it like so. Now what we're going to do is we're actually going to take our floating point number, multiply it by this random number which gets generated, and then divide it by our constant value here. This will actually give us a floating point number so that we can return it to fval. And the output will actually give us decimal numbers. So there we go. We can actually see the output a lot clearer now, and it's not getting clipped because they're no longer integer numbers that we're working with. We're actually working with floating point numbers. So you can see here, our first number was 1, and then we have 5.65, 7.58, and so on, all the way to 102.27. Now, if you do this on your computer at home, you should see some different numbers here, and the numbers that you see will be dependent on a couple of different factors, actually. But you may notice something very interesting. Notice that if I run my program a second time, I get the exact same numbers. And as a matter of fact, if I run it a third, fourth, fifth, 100th time, we will always get the same random numbers. And the reason for that is because the C++ random number generator is actually basing its random numbers on a certain seed value. So you need to be able to change that seed value so you get different kinds of random numbers every time you run this rand function. And the way you do that is by calling the following function. srand, and then you want to type in some value in here. So if I type in 1, then let's try this out. Control F5. You notice that we have number 97, 81, and then 102, 27. Now if we change this number to, I don't know, some other number, 154, then our numbers now that are getting generated are different. So depending on what number we type in here, we're going to have a different random number generation as we run our program. Now, to always have a different number inside of this srand seed, what you can do is actually use the current time as your seed value. In C++, to get the time, you can call time, and it accepts one parameter, but you can just set it up to be equal to 0 so that you can run your program. Now the other thing is that time itself is going to return a time underscore t variable, but srand needs to use an unsigned integer. So you can just cast this as an unsigned int, since you're not really interested in the actual value of the time. You just need some number. It doesn't really matter what it is. And if you go and compile this, oh, you get errors because, let's see, all right, time is currently not identified because you need to include, I think it's time.h, so that the compiler knows what exactly time is. Yeah, so there we go. Now you can see that our second last number here is 99.31 and 107.52. If we run it again, we get 99.05 and 105.04. One thing that I noticed when I did this, though, is that the very first number is always 5.54 on my computer. I don't exactly know why that's happening. 5.54, 5.0 is 55 now. So the first number always seems to be very close to the number that we're always getting. What you can do is just take this time value and multiply it by another time value to randomize your seed even more. So now we get 782. Now we get 2.25, 5.59. So now it's giving us more of a random set of numbers. So you can go ahead and play around with this. This is how you get random numbers to get random every time. This is how you get a random number, and again, you can multiply it by any number you'd like to change the range value that you would like your random numbers to be from. And using this while loop, you're basically running through here a certain number of times until you meet your breakout condition. If you never meet this condition, you'll be running in this while loop forever. So make sure that your breakout condition is something valid that you can achieve. Because I'm always adding positive numbers, I know that eventually my floating point value here, the sum, is going to be greater than 100. Okay, so those are looping structures. Basically, what you want to remember is the while loop and the for loop. For loop is for a fixed number of times that you're looping through a structure, and a while loop is basically a loop structure that you do until you meet a certain condition.